Hello and welcome to another episode of the Oxford MAT Livestream, except today it's the bonus, not MAT Livestream. Let's write that on the screen. Bonus, oh no, tiny. Bonus, hooray, not MAT Livestream. We've been talking about math problems for the last 13 weeks or something, and yesterday there was something which I think might have been a math live stream going on there. It might have been a math paper that actually happened yesterday. And my plan for today was to not really talk about it. If you want to talk about the math in the Slido comments, then that's fine. But otherwise, I'm going to try not to talk about it too much. We've got a stream in a couple of weeks' time to talk about all the gory details of all of the questions. And this one is not Matt. So people's opinions are going in chat. And I suppose what I'll say is that the paper has been posted to the MAT website if you want to see a copy of the questions, and the 10-minute video where I go through some solutions has been posted to the main channel as well. If you were really quick on the main channel, you might have seen a version that I made this morning that got almost instantly taken down because I made an embarrassing mistake. So how's your morning, chat? How's your day going today, chat? Let's just vote for today. Let's vote for today, not for yesterday. Yesterday was yesterday. Today is today. I would like to know. So there's a 1 star's coming in fast. Okay, cool. Point taken. And I think the tricky thing about this live stream is that people are cross and probably cross with me. I suppose maybe if you're cross with me, you're not watching. So maybe I'll assume people are not cross. Oh, loads of votes for complex numbers. I haven't even asked for a vote yet on what's going on. Groovy. Okay. People are voting. The average is, of course, lower than normal, and I get that. And I think what I want to pull out from chat is I saw a couple of people saying that they were disappointed, or it feels like feeling dejected. That will pass. Eventually, you might feel right now like you don't want to do any maths problems, you don't want to see any maths. That will pass. Some advice I was given once was to say that for almost everything, that this too shall pass. And if you're feeling dejected right now, then this too shall pass. I had a similar experience where I got back from part of the admissions process and thought that I'd done really terribly. I'd made horrible mistakes, and I thought that's completely over then. And that's not how it actually worked out, but it was close enough. At the time, it didn't make sense to, I guess, tell me that that's not how it's going to work out. At the time, it was pretty dejecting. Okay, people in chat seem to like question 5, which is, I mean, that is encouraging a bit. I'm going to try not to talk about the particular questions too much. I suppose I should probably come clean so that you can decide whether you hate me or not. The only thing I'm going to say about Matt today is that I was in charge of questions 1, 2, 3 and 4, and the computer science department were in charge of 5, 6 and 7. I agree, question 5 is lovely. I really like question 5. Good, okay. And I'm going to call out one person in particular as well here. Not call them out, but just to try and do the pep talk that I think you need right now. Because the average is 3 with a big chunk of 1 stars. But look, you've turned up. You're here and being 1 star here. I'm going to pull out one person who says, I feel like I just wasted 4 months of my life on revising for the exam as the paper was so understanding based. I don't think you wasted 4 months of your life at all. I think that, and maybe I'm being naive, I think that preparing for math and doing these things that we've been doing together, of practicing maths questions, has helped you, I hope, with maths problems and getting better for other things that are going on this year, and other stuff that's coming up later. So that maybe you don't feel the benefit right now, but maybe you practicing these maths things has helped you in ways you can't even tell. Right, okay. Oh, someone hated question 5. People are cross with me about question 2. That was me. It's not even my style of mathematics. Okay, so that's the pivot where, it's very off-putting in a way to do the live stream where everyone's unhappy and then you try to just not talk about it. It's very tempting to just talk about it, but I think I've already said quite a bit. And I think it would be fun if we talked about something completely different. Oh, what did James Bond say? You've got an agreeer. Someone's agreeing. I can't remember what James Bond said though. Okay, never mind. And Kai says any revision for math doubles as revision for A level. And loads of people are saying, James, what did you set the worst math question to ever? Or great. The markers are going to be really nice. I'm in charge of the marking team. Maybe that's bad news, I don't know. The markers are going to be nice. I always tell them to be nice. Feels like 13 weeks for nothing. There's not nothing, right? There's not nothing. Right, okay. Prisma's doing a great job getting through chat, which has gone quite talky. You are personally allowed to talk about the test. The test paper's been posted to the internet. People are discussing it. This stream's not going to be about that though. Instead, I wanted to talk to you about some not math, the stuff that's just not on the map but is out there and interesting that you might be interested in. My two kind of ideas for this were kind of graph theory and the kind of other bit of the Euler diagram, Venn diagram, is stuff I can't do. I thought it might be cathartic, perhaps, for you to see perhaps some stuff in one of these zones where it's something that I can't do, to see me struggling with some mathematics. Because maybe if you've been struggling with mathematics, you could be struggling with seeing me struggling with some mathematics might be fun as well. And I also put in an option into the poll to just ruthlessly make fun of me. So we'll see how that one goes as well. It's a what next poll like we've been doing for the last few weeks. I think I'm going to add complex numbers to it, just because people in chat seem to want complex numbers. I'll have to work out what I'm doing when we get there, but you know, we'll get there when we get there. There's a vote. So the options are, from my point of view, I guess, the options are graph theory that I know, graph theory that I don't know, where I try and show you some graph theory and work out how it works along the way. One option is an integral that I can't do, but I do know the answer, where I try and explain to you an integral, but I can't do the integral, so there's that element of it. One option is thesis.pdf, mock my personal statement again, and complex numbers is one of the options as well. Mock the personal statement's going really well. Right, okay, I'm going to have to work out how to do one of those things where I've seen these on live streams where people have like the video playing on YouTube and then they try and react to it live. Become one of those ones. Some people in chat liked question 2 or something, or some people think it's just terrible. But it's still interesting that you've come back. Hardest multiple choice ever, but somebody likes the sign things. Mames John Rose accused me straight up of lying. Good times. I think this. So maybe some of these options are the ones where you make fun of me doing well. What my personal statement's doing pretty well, and integrals I can't do are doing well as well. So that's nice. There is error carried forwards in the marking where it's appropriate, where that makes sense. And somebody says, "Wish I didn't watch the 10-minute video." So I guess that's a warning. If you don't want to see the video, please don't watch the video. It's not on the Central University, it's on the MAT website. If you're on this website, I think there's a link in the description, or roughly the link on screen to the MAT live stream. It takes you to the Maths Department website, that's where it's currently living. Good, okay, I'm sort of going to wait for the vote just to see if the vote changes at all after that. Just see, maybe it might settle down, right? There's some votes for graph theory, but graph theory is way down. Okay, so my plan this morning was to do graph theory, but that's not getting the votes. Not so much as something like this. Okay, right. Time to find my personal statement. So a couple of years ago, we did a video just tearing apart my own personal statement. And I think my plan now is to try and do a reaction video to that video. So sorry, most people didn't vote for this, but some people have. So now we're going to make it happen. The place I'm going to go is that website to find the MAT live stream. I should have had this loaded up ready to go, right? Because I should have guessed that this would be the most popular thing straight off the bat. Let's close this poll. Let's close it when it hits 100. Hi everyone, by the way. I'm James. I write MAT questions, and also sometimes I write terrible personal statements, which I've done exactly once, I think. Let's see if I can find it. Is it on this channel or on the old channel? The main channel. Sure, chat's being helpful. Yeah, here we go. This is it. Was the second result? But no, it's not. Okay. I thought maybe I'd rickrolled myself by loading this. Okay. Does that work like that? Okay. This is a MAT Livestream bonus from 2020 or something like that. Oh, chat's stalling a bit. Have we lost the internet? No. Okay. Has that hit 100 votes? Not quite. Good. Right. Let's turn it off anyway. Go back to chat. Oh, somebody likes the hundreds. People are talking about. People are talking about that. Right. Good. Okay. I think. Let's check the levels. I think this captures sound, but I'm not sure. Let's just have a quick blast of this.
It's not.
Yeah. Okay. Right. There we go. Right. Good. Okay. So this is a 10-minute video that goes through my personal statement, and oh boy, my personal statement is pretty cringe. So let's have a go at this. I'm not sure I can do this and chat at the same time. Oh, somebody's linked to the test in chat, so that's good. Oh, the answer. People didn't like the answer video. Oh no, how can I convince people not to watch the answer video? Right, okay. Hopefully I've got the level set so that you can hear this as well. And it's going to be, I suppose, 50% making fun of my personal statement and 50% making fun of me 2 years ago, making fun of my personal statement. Let's go.
It looks like you're voting for the personal statement, so I'll get that ready. I've got a little bit of while. This is going to be incredibly cringe.
Incredibly cringe. Sorry, I'm one of those people who pauses the video while it's coming back. You can't quite see beneath. Can't quite see the terrible combination of haircut and glasses that's going on in the bottom right corner. Let's try and work out if I can get that on screen.
It's not going to be great.
I need to make this the animation.
Here goes. So, disclaimers.
Yeah.
This is my personal statement from
My personal
UCAS.
statement.
I saved a copy of it. It's from 2009.
I'm old.
It's not very brilliantly written. We're going to react to it as we go through. Things you need to know about me. When I was in school, I was extremely keen about maths.
Massive nerd. I was like, what is this? This is terrible. This is awful. Can we zoom in on this? No, we can't. This is just awful down in the bottom right corner. So sorry about that. James reacts to 17. James reacts to previous James reacting to 17-year-old James. It's very
obvious. I was also probably too confident, and so this is. Oh. I've grown a lot since then, but we're going to do this. Okay, right.
Have I grown enough though? Let's find out by watching this cringe video from 2 years ago about a cringe personal statement from about 10 years ago.
You ready? So it starts.
Loud pen noise.
Mathematics is at the centre of everything in my life.
There it is. That's literally the first sentence of my personal statement. Whatever the first sentence of your personal statement is, it's probably not as cringe as that. So that's pretty bad. So there we go.
Which is such a cringy start. I wish it didn't start like that. That's a full stop. That's a full sentence. Maths is at the centre of everything in my life. I wish I didn't say that. Oh well. So that's a dramatic start, I'd say. Do not recommend this. Whether I'm in the classroom or at home, I'm always trying to prove a theorem, work through a problem, or just solve a puzzle.
Someone had told me that the rule of 3 there, to put 3 things in, and put the commas in between to have 3 things as your example.
I like doing maths puzzles, and that's I'm fine with that. That stood up to the time. I like to prove mathematical facts for myself, and I'm currently working on a proof that a hanging chain forms a Koch curve using techniques I learnt while teaching myself mechanics units. Okay, so this sentence is trying to do quite a lot. This is trying to say I like math.
What was that? Sorry, just on the 2 years previous. Quite a lot. What is that? There's so much mouth noise on there. I'm just backing it up. Sorry, everyone at home.
So this sentence is trying to do quite a lot.
It's a really weird way of talking back then as well. Who knows? Maybe we're reacting to this video in 2 years' time, and my square is up there somewhere, and you're making fun of my voice now. But gosh, that was a weird moment. Trying to prove. I think we're going to call this out 2 years ago as well. Currently working on. Very good weasel words.
This is trying to say I like mathematical proof. I'm working on a proof. I think is an excellent structure. I'm currently working on a proof means I don't know why this is true. I was hoping to maybe have proved this or worked on this in time to write my personal statement, but I haven't, so I'm currently working on a proof, guys. I'm still currently working on a proof that a hanging chain forms a Koch curve. I don't know where I got that fact from. I think it's a fact. I think it's true.
It is true. I can't believe that 2 years ago me still doesn't know whether that's true or not. We could do that. We could do this proof afterwards. No, we did it on the Maths Club as well. Goodness me.
Anyway, and I've been reading mechanics textbooks because I'm a nerd like that. I've been reading textbooks. I also like to solve mathematical puzzles as rigorously as I can.
Oh my goodness. Sorry, for the rigorously, which I don't think I called out last time. My goodness. No one cares if you solved a puzzle rigorously or not.
And so I'm working on a proof that a pair of dice labelled 1, 2, 2, 3, 3, 4 and 1, 3, 4, 5, 6, 8 is the only pair of six-sided dice other than the standard six-sided dice, for which you have a 1 in 36 chance of rolling a 2, a 1 in 18 chance of rolling a 3, and so on, as for normal dice. Two things to say about that sentence. Firstly, there it is again, I'm working on a proof. I was really proud of finding these dice. I thought it was a puzzle that I came up with myself, and I thought about trying to solve, and I found it has an interesting solution, so it's all very nice. I made you do it as a bonus problem a couple of weeks ago. That problem's from my personal statement. So
I've always been evil. I've always been trying to get other people to recreate maths that I've done. Should we do the puzzle? Should we do the proof? Should we do the extra thing? If you've just joined us, the reason I'm not limp synced is because I'm reacting to a video from 2 years ago where I mocked my own personal statement. This video is now a reaction video. I've seen these on other people's live streams, except I'm using my own content, which makes a lot. Kai's asked in chat how many sentences start with I, and I haven't been counting, but this one does, doesn't it? Too many of them, maybe? Oh gosh. There's a comment at the front there that this is too confident, which I don't think anyone's ever been told that they're too confident before. Maybe more people should be told that they're too confident. I believed in myself, maybe too much. Good, right, if this gets in 2 years, include this comment in the screenshot. Wait, where's it gone? Just 45 times. No, really? Is that a real fact? 45 times that possibly 45 sentences start with the word I. That would be an amazing stat if true. That is big if true. Right, good.
Okay, there you go. Power move.
We should do this.
Okay, right, next sentence. We're doing one sentence at a time. Recently in my spare time, I've worked through the first chapter of, and then there's a book name, RBJT Allenby's Rings, Fields and Groups, to gain an insight into the form of a mathematical proof, and to challenge myself with concepts that I was unlikely to meet inside my mathematics syllabus. So this says I'm trying to read a book, but it's not going very well. I think I found a maths book in, oh gosh, school library or like a library or something, and this is just a random maths book. I can't remember what's in the first chapter of this book. I've worked through the first chapter, it means I've steadily looked at some maths book, and I'll tell you now, I don't think I really understood what was in the maths book that well at all. Okay, it keeps going.
Wait. Insight into the form of a mathematical proof. Oh, that was somebody saying what their math result was. Oh, sorry. You don't know. We might mark it more generously than that. Oh my goodness. There's so much to dig into here. Somebody else told me to put a capital M on mathematics. That's not just me. That wasn't my idea. I'm not sure why I didn't put a capital M on mathematical for consistency, but hey. So much going on. Insight into the form of a mathematical proof. I don't know what's that trying to say? I was reading to get insight into the form of sentences. Is that something that English students say? Challenge myself with concepts. My mathematics syllabus. What is this nonsense?
We now have a sentence that's kind of a review of this book based on the first chapter. I was particularly interested, says James from 2009. I was particularly interested in the care taken in mathematical proofs. For example, when mapping members of Q of X to members of Q. That's a random thing from the book. This inspired me to attempt.
Wait, that Q of X fact is not even that interesting. We can try and do this afterwards, but it's not interesting. I don't know why I've ripped out one random sentence from the first chapter of that book I was looking at and just, that sounds like maths. Let's put it in the personal statement. It's not. And now mathematical has a capital M. Didn't before, but now it does. Oh, what is this? Q of square brackets X as polynomials. I don't love it. Don't love it.
That's a random thing from the book. This inspired me to attempt an extension of some of the proofs given in the first chapter to other sets of numbers, such as the H numbers. And there's that weasel phrase again, attempt a proof. Attempt an extension this time. Once again, I'm trying to do some maths, but nothing to report. And H numbers, I honestly, this day, can't tell you what an H number is.
And I haven't looked them up since.
Goodness knows. I imagine it's in the first chapter of that book. Who knows? Who knows? Worked on a proof. There we go. Okay. Over my summer holidays, I wanted to achieve something constructive, says 17-year-old James. So I taught myself 2 mathematics units, 2 examination standard. Was it examination standard, James? Was it? What does that mean? M2 and M3, which included topics such as circular motion with variable speed, simple harmonic motions, and impulse in 2 dimensions.
People know what... So units aren't a thing anymore, but back then M2 and M3 are just names of units. People know what's in M2 and M3, or they don't care. There's no point listing... Just like... Here's some of the A-level syllabus for you to look at. Amazing, yeah, and it is waffly. I'm actually not sure if people are waffling... calling me waffly now, or waffly in the past, or waffly in 2009. Maybe all 3 of those people are quite waffly.
So here I've said I've read that mechanics textbook. I'm trying to mention that mechanics textbook again. I really like math and physics, so I looked at a mechanics textbook, and I've listed some topics from mechanics, which is silly. It's just using up words on explaining what's in maths units. I also read material from M4, says James happily. I read some material from M4, but notice how this is excluded from the 2 examination standard claim.
That's past James. Now this is an interesting moment. That's past James from 2 years ago doing false modesty, because 2009 James did actually take M4 to exam, did actually do the exam, and did get a high mark in it. That's something we should be proud of for past James. But look how 2 years ago James is pretending like, was it examination standard? He knows full well that it was. He knows that he did that exam. He's lying to you about whether or not he did. So this is sort of an interesting effect, that this is so cringe that previous me is trying to distance himself from really old me. Let's just hope that however your life's going, it's not going to get to that point.
I also read material from M4 and FP2 to learn further mechanics and integration techniques to help with my study. For general interest, I also looked at topics from FP3. I found this other textbook and I looked at it. Particularly the chapters on set 3. Gear change. That's me listing some books I've looked at. I've looked at pretty nerdy maths books. Cool. For general interest... Oh, no, hang on. Where are we? I'm interested in mathematics education, says James, brightly changing gear. And so I've been helping teach mathematics at local primary school, as well as mentoring a Year 7 student at school, helping to train the junior teen challenge team, and volunteering at the Royal Institute once monthly, explaining science and maths topics to members of the public. From this, I've gained confidence and experience in communicating and explaining what I know, and I feel that I've demonstrated my ability to commit to a task. I actually quite like this pair of sentences because it shows that 17-year-old James, not for admissions or anything, but it shows that 17-year-old James was interested in communicating about maths, which is now what I do as a job. So that's quite nice to see. Well done, 17-year-old James.
Still waffly though, isn't it? Still a bit weird, still a lot of text. I'm still sort of proud that the previous James did that and that previous James did that, but still, a lot of words and personal statement. I don't think it works for admissions, but never mind.
My exam results reflect my interest in all areas of mathematics, with UMS scores over 90 in all my AS modules. There we go. Does that make any difference? I don't know. The AS modules aren't even a thing anymore, so there we go. I haven't found anything covered this year very difficult.
This is actually the worst bit, right? This is actually... I'm sort of proud of it as a claim, as a boast, but it is not humble at all, right? The sentence there, I haven't found anything covered this year very difficult, comma. It's nothing there very difficult. Oh my goodness. Wow, brilliant. This is time borderline cyberbullying, but also time travel cyberbullying, and it's also me in the... It's me in the video.
Humble brag. But I did enjoy studying mathematical induction, as it introduces the concept of mathematical proof, and because its applications to problems are highly varied. Okay, so I'm trying to mention a thing I like again from maths in school. In the last few years, I've taken part in 6 maths challenges.
Mathematical's got a capital M again.
From maths in school. In the last few years, I've taken part in 6 maths challenges and 3 intermediate Olympiads, and I've sat the BMO twice. In 2009, I performed well enough in BMO.
Just moving straight on, like, just turned up for some things. Don't ask tricky questions, like, how did they go?
To qualify for the UKMT initial training camp held in Oxford. This taught me problem-solving techniques and let me study mathematical topics, which are part of my syllabus, such as geometry and functional equations. So I was...
Part of my syllabus? What is this, kid? Right? It's the second reference to my syllabus. What does that mean? What does that mean? Functional equations is such a weird pick. That's just... What? What is my syllabus? You don't get a personal syllabus. That's not a thing. Brilliant. Right, okay.
Was lucky enough to go to some UKMT maths camps. I think I mentioned a couple here for doing maths challenge stuff, which was great fun. None of the maths on those camps was relevant to university maths. I mentioned geometry, none of that geometry came back again, and functional equations, which is basically like the functions we've been talking about before.
This is also the point of the video where the views massively drop off. I don't know what it is about this bit in particular. I think it's just got a bit boring at this stage. So let's talk to future me instead. That sounded like a fun idea. Hi future me. I hope you've worked out how to do a live stream stably, because this is, pretty up and down this year. Good on you.
Okay. I also enjoyed being part of a community of mathematicians, which gave me a chance to talk to other people about mathematics from school and outside of school.
Mathematicians get a small m, but then mathematics. Okay.
Here's my favourite paragraph at the end. Outside of mathematics, I realise I've got two sentences to go, and I have only talked about mathematics. So this is a sentence that starts, outside of mathematics, I also play the clarinet in the school's wind band and sing in the chamber choir, and I've recently started a juggling club. Extracurricular? Anyone? That's my sole concession to non-mathematical activities.
Except all of the teaching stuff and the other bits and pieces. I think previous James makes fun of previous James too much for doing extra bits and pieces. This is cringe at the end as well. You've got to bookmark it with the proper cringe.
Overall, I feel that I'm well suited to studying mathematics at university, as I have the talent and enthusiasm necessary for such an intellectually demanding course. That's the end of my personal statement. Gosh. It's very intense. I think my main thing that I learned over the last 10 years since I wrote this is I learned to calm down a bit. This is pretty full on. I looked at a textbook once and I tried to prove a thing.
Bad news, past James, but not past James. Past James is now the only thing on screen, which means we're rinsing you. I'm really struggling to find words to explain how your personal statement doesn't need to look like that. Hasn't quite realised yet that this is going to get thousands of views on YouTube, and people are going to think that their personal statements maybe need to look like this one. Doesn't do a very good job of telling them that it really shouldn't look like this one, or not shouldn't, but doesn't have to. Oh my goodness. The juggling club didn't even, I think that's a lie. I don't think I called it out in the previous run through. Sorry, I've been half listening. Was there a juggling club? I don't think there was a juggling club. Also, what's an H number? Somebody in chat's googled H numbers for me and not found anything, so that's one of those mysteries. I guess our challenge now of chat is to invent H numbers. So it says, wow, juggling is actually a skill, and they've put their username down as juggling pro. So that's pretty good. And people want to know if why would I lie about a juggling club? I think I had the intention to start a juggling club, but then didn't follow through. I don't know why I lied about it. It's such a weird lie as well. Brill. Okay. I don't know where the clarinet is. People are voting for clarinet in the thing. I don't know where the clarinet is. Right, we've got about a minute left of rinsing previous James, and then I suppose I should record some minute more stuff so that future James can rinse this bit.
And that enthusiasm really helped me at university. I think it's important to follow up this reading my personal statement by talking about how personal statements work in applications. For mathematics, I think a lot of personal statements look a bit like this one, that people are interested in maths, people are interested in bits of maths, maybe talk about your favourite bits of maths, maybe try and prove stuff. I'm lucky that I had the chance to do some UKMT stuff as well, which was great fun. Meant that I got a sentence in there to just list some UKMT stuff. But now that I've seen a lot of personal statements from applicants, the way Oxford works is your personal statement goes to tutors at the college you've applied to, but also the admissions coordinator, which is me. I get to see everything. So I've seen thousands of personal statements now, and
that's a bit of a lie. I have access to thousands of personal statements. It's a bit of a lie. He stopped short of saying that he's read thousands of personal statements, but still. People in chat now think that H numbers might be the harmonic numbers. I'll have a look.
Most personal statements say pretty much the same. You could summarise them with the same bullet points. That I like maths, I'm good at maths, I'm looking forward to doing 3 years of maths, and I like trying to solve problems, and I think maths is really interesting, and I like how maths is true. There's a lot of repeated themes in there, and that means that it's basically impossible to separate people, especially at the level of Oxford.
I do love the phrase. I think I like maths. I like how maths is true. I do love that. I wish I'd put that in my personal statement. Would have given me something else.
It's basically impossible to separate people, especially at the level of Oxford applicants, based on their personal statements. It's the main reason that we get used to the maths admissions test. And if you do well on everything together, then we invite people to interview. And we do some maths problems there as well. That's a lot of maths. That's much more interesting to us than how you write your personal statement. Okay.
So this is a very strange video. It's for some reason got about 300, what are they called on YouTube? 300 of these. I don't know how many of these it's got. Actually, not insignificant number last time I checked. It's got 12,000 views. I sincerely hope that, however your life's going, it doesn't end with 12,000 people seeing your personal statement and then a further several people watching this making fun of it. We're going to interrupt this live stream briefly to say congratulations to Gonzalo, who during that personal statement segment got an offer from a university. They got an offer from Warwick. Hooray! So that's great. Well done there. That's so far best thing. Somebody's asked me in chat if I know what Pell's equation is. Oh, I've got such bad news for you. Yeah, I'm sorry. I do know what Pell equations are. Funny you should ask. It's unrelated though. Anyway, right, cool. People are still trying to make the link as well. Gosh, that personal statement's bad. Let's put that in the category of stuff I can't do. It's nothing to do with graph theory, but here's an element of this bit over here. Write personal statements. My goodness. Lots of questions there from people asking what my MAT score was. I didn't apply to Oxford. Lots of people asking if anybody applied to Cambridge. Yes, me. And lots of people wanting to know how my time at Oxford went. No comment. I didn't go to Oxford. Galois theory. Yeah. So Mames Jummer has remembered. I tried to learn Galois theory once. I had this half idea that I would try to learn stuff, like stuff I can't do. I tried to learn it on stream. Let's have a quick look at Popular because I've been asked to look at Popular. Oh, it's Gonzalo twice. Oh, well done, Gonzalo. You have the 2 top comments right now. I want to know how people did if the answer is badly. Otherwise, please keep your glee to yourself so we all feel better about our performances. And a request to interview more people because of Matt. Carl Frederick Gauss thinks that Q5 wasn't that bad, but thought that my question 2 was the worst. I don't think I'm allowed to encourage people to drink away the pain. Born a year earlier, so we could do Matt 21. What does Prisoner think about that? Anyway, right, cool. That's top comments. Let's go back to recent. What questions did I make in Matt 2022? 1, 2, 3, and 4. Right, okay. What is this live stream doing? This is a bit weird, isn't it? We've just been making fun of James. Let's do the vote again. Or let's have another look at the vote. I can't remember what came second. The integral's doing pretty well. Let's edit this. We've done the mocking my personal statement. Not again. Don't vote for it again. This isn't the Teletubbies. You don't get it again. We're not watching the video again. Is it too lazy for a live stream to just play back videos we had from before? But goodness me. What does this even say? Can we rinse this in the future? James's handwriting, like supercut. Right, good. Okay. Integral time. It might be integral time. I think it's got some votes for integral time, and it's also thesis.pdf is coming second. Oh, complex numbers is catching up. Complex numbers haven't caught up. If you get rejected, so a suggestion in chat there, what's going on if you get rejected? If you get rejected, you can still go to a different university, and other universities are available and are pretty great. So, the way this works is I need to show you an integral that I can't do. It's in my thesis, which is not a brag, that's just where I keep things. I need to show you this. Okay, I hope that's on screen. Oh, it's tiny. Can we put it not in read mode? How do PDFs work? One page? Yeah, there we go. Okay. So, somewhere in here, I had to do loads of calculations in this, and there's a calculation that I can't do, but I know the answer. So I'm going to try and explain it to you, and then if you can do the integral, then that's brilliant. You've finished off something that bothered me quite a lot during the PhD times. Will the live streams continue in January? Hey, in January we run this thing called the Oxford Online Maths Club. If you search for Oxford Online Maths Club, you can probably find it. Have a look at what we're up to over there. Let's see if I can find this bit. Yeah, so there's a numerical bit in here. Is it this one? Yeah, this is going to be hard to explain, chat. But there's a numerical thing. Are we in 2D or 3D? Oh gosh, I should have prepped this a little bit more. Sorry, chat. Yeah, we're in 2D, so let's go 3D. How do I get to 3D? Okay. This is not going very well, but hey. Here's 3D. No? Yes? Good. Okay. So, the way this works is, I had to give an integral to a computer. I gave the integral to a computer, and it came out with a very particular number. In this expression down here, let's zoom in a bit. Fit width? Yeah. In this expression down here, there's this number 0.2688, which then gets rearranged quite a lot, and there's a lot of stuff going on, and it rocks up as this number 1.807. And the punchline for what I'd like to show you is that 1.807 is more or less exactly a very particular number. The very particular number is 32 over 3 to the power of 1 over 4. Oh, people are getting Warwick offers in now. Oh, this is such a happy live stream. Look at this. An anonymous person just got a Warwick offer. Although I'm worried that people are going to be refreshing their emails and then drawing conclusions from these. Oh my goodness. Right. Okay. Okay. We've got some numbers. The numbers kind of come out of nowhere, and I sort of know what the value has to be. So there's a complicated process, and a number falls out the bottom. I sort of know that this one at the end, what I was expecting to get, was 32 divided by 3 to the power of 1 over 4. I think that's true. Let me just check that on a calculator. 32 divided by 3. Oh, come on, calculator. No. 32 divided by 3. Why can't I divide? 32 divided by 3 to the power of 1/4. Yeah, 1.807. Yeah, okay. So this has come out of some complicated computer integration stuff that I did, but this is supposed to be 32 over 3 to the 1 over 4. Let's work out why. Okay, on with the integrals. It's pretty tough. I've picked up something that I want to show you the integrals that I can't do. So let's try and piece this together. I'm going to try and go split screen. I think I know how to do that. Let's go split screen like this and bring this one down, get that out of full screen mode, and put it on the right so we can take notes on the integrals as they come up. And this is where Windows comes into its own. There we go. Okay. So now I've got stuff on the left and I've got integrals. I can take notes on the right. Hey, this is almost like this is what live stream should look like, right? Okay, so on the left, the thing I remember is that this integral I had to give up and just do this with the computer. It's got these omegas in it, and it's turned out to be this number. I would really like to know what that number actually is. I need to tell you what omega is. Omega is a solution to a differential equation. Let's try and find the differential equation. There's quite a lot of this, which I don't want to bore you with. Okay. So the differential equation is this. Oh my goodness, it's a bit precise. It's minus 1/16 is equal to the second derivative, so it's prime for that bit, minus omega prime plus 2 omega prime plus 3/4 over omega. Oh my goodness, so I had this differential equation. Down here, which I had to solve for omega, and what do I want? I want one of the particular solutions to that, because it's got lots of solutions. I want to take one of the solutions for this and plug it into this differential equation. to get this number, and I'm going to do some more stuff to that number. And the annoying thing is that I know right down the bottom, after doing this and sort of cheating by putting the integral into a computer, I solve the differential equation with the computer, put the thing into it, put the solution into a computer to integrate it. I sort of know that at the end of the process, I'm supposed to get 32 over 3 to the power of 104, but I can't work out why. So this is confusing. Yeah, my goodness. Oh, somebody else has got one. Oh, a couple of weeks ago though. Good. Okay, let's see if we can make any sense of what's going on. I thought to show you things that I can't do, it would be a fun extra way. This gives me something to make fun of in the future, right? Okay, so I've got a hideous differential equation. This has come from the kind of momentum equation. I'm solving a fluid dynamics problem where we've got some forces and then balance. The forces balance the inertia. They sort of change. Forces balance to. Goodness me. F equals ma is the. Let's not write F equals ma out in words. There's some force balance going on, which is giving us this differential equation. Differential equation has got some solution, and then overall, I'm trying to add up. I'm trying to add up for this integral up here. I'm trying to do this calculation to check how much fluid I've actually got in total. I sort of know how much I've got in total, because I know that also separately behind the scenes, I've got conservation of mass. So in physics problems, I know we've got a couple of physicists in. In physics problems, for classical dynamic stuff, you often use these two rules, or maybe you use conservation of energy and conservation of mass. Those things are pretty helpful, and they give you these conservation laws. Here I wrote down my differential equation, I had to get a computer to solve it, and then in trying to get all the pieces to fit together, and for it to fit together eventually, I know that really down the end, it's got to be 32 over 3 to the power of 1 over 4. I'm not making much sense, but that's because I'm talking about something I don't know how to do. People in chat, not interested, I think. If we can do this, then yeah, definitely. I think we can put the name on the paper. I can't remember why I'm using omegas all the way through. Let's try and work that out. Let's have a quick look over in thesis.pdf. So I think omega is something to do with the sheet velocity or the thickness. Scrolling back up. It's how you read maths work, even if it's your own maths work. Scrolling back up. It's the velocity, because this has come from the Navier-Stokes equation. Why has he got two derivatives? Viscosity. Okay, cool. Right, brilliant. Horrible, complicated integral that I can't do. But hey, I've got some nice pictures. Good. Can we separate variables? Yeah, I'm sure I've tried hitting with stuff. The thing is, this omega plus 2, this is what horrible research math sometimes looks like. This omega prime plus 2 is the same thing. So we can do the substitution where we could rearrange the bottom equation and just plug it in, and then we're kind of using the fact that it satisfies the differential equation. But the terms that you get out are really horrible. It's kind of that divided by the omega as well, right? So this is precisely kind of the stuff that's in the differential equation. So if you rearrange it, but you get these things with the second derivative and divided by the first derivative, but it's not quite the nice combination that you want it to be. So it's not just, I really want it to be nice. The top's not the derivative of the bottom, right? Can I make it the derivative of the bottom? Yeah, something like this. So the fractions like, things we know how to integrate, right? Are things like f prime of x divided by f of x. We know how to integrate that one, because that's just natural log of f of x plus a constant. That would be really great if we could do that. Unfortunately, I've got a 2 over omega as well, and I don't really know what omega is. I don't have a nice expression for what omega is. So this has defeated me for several years as being just too much. So the integral calculator, I don't think you can give it. I don't know what the functions are inside my integral. They're solutions to this differential equation. I don't really know how to approach that, because I would love to just stick it in an integral calculator, but I literally don't know the functions that are inside here. The functions are solutions to a differential equation. So this is kind of my problem really with PhD maths or research maths, was that everything was so complicated, and so this thing leads onto the next thing, onto the next thing. There's so the chain of understanding, and I only got it to the point where I just about understood each link, but I don't feel like I got to the point where I understood the whole picture in one. I can't see it all at once in one go. I think I only got to the point where I understood each link one at a time, which is why when I'm trying to explain it to you, I've got to show all these tiny bits. I've got to scroll up and down and show you, oh, omega's one of these, and there's a differential equation that came from somewhere else. The differential equation turned into this, and then they've come back. It's 32 over 3 to the 1 over 4. And that's really disappointing. And I feel like what I'm missing is a way to get all the way from the start to the end. Just tell us a nice story. Somewhere buried in here, I reckon there's a good 10-minute YouTube video, but I haven't found it yet. Good. Okay. What did I think about Barry and his blog? I don't know what that was. Maybe link it. Did going to Oxford make you smarter or just make you know more? I didn't do that, so no comment. I think it made me, university in general made me calm down quite a lot. I said that in the 2 year ago video. And also made me meet new people and calm down a bit. Yeah, no idea what's going on, right? You put it all over one fraction? Yeah, it's a good idea, really. So if I multiply this by 8 and I multiply this by omega, or minus sign. Yeah, then the top's looking a bit like the derivative of the bottom, but there's also this eighth is annoying. The eighth is necessary. I know how to integrate the eighth. This is really annoying. I know how to integrate 1/8, right? 1/8 integrates to x, but it's necessary so that this integral gives a number rather than, because if you just integrate 1/8, here's an integral that I can't do for a good reason. If you just integrate 1/8 from 0 up to infinity, you get 1/8 x from 0 up to infinity, and that's infinity, which is no good. You need the other stuff in there to cancel it out. Well, was I the best in my year? No. I was okay. I was good at applied mathematics. What was Trinity like? Yeah, it's surprising that this even works at all, right? It's just some random omegas and then solutions to differential equations, plug them in, and then my word. Yeah, so I'd really like it if someone could just do this. Maybe black pen, red pen suggestion in there. Barbarian King wants to know if I got a girlfriend. Sure, yeah, I met my partner at university. 1/8 integrates to x, is that something I said? 1/8 integrates to 1/8 x. I look forward to the video in 2 years' time where I make fun of myself for this. Mat review in a couple of weeks. We'll do the mat review in a couple of weeks. I don't want to do it now. Time for chat to just solve it, right? That'd be good. Yes, I have thrown weird vector calculus stuff at it. There's a suggestion of some weird vector calculus. I learned a lot of weird vector calculus in university. Question for the person who asked it: does that make me smarter or know more stuff if I know some vector calculus now? Didn't help me do this integral, so who knows? Okay, this is a bit of a weird live stream. So far I've shown you an integral that doesn't make any sense that I can't do, and a personal statement that I consider to be a bit rubbish. People are unhappy. Right. Did I do any theoretical physics? I sort of think that, yeah, this is theoretical physics. We'll find out. Oh, someone solved it in chat, but they didn't. The chat limit is too small to explain why. Everyone's saying Riz. Am I gonna have to look up the word Riz? Oh my goodness. Oh right, okay. I've learnt a word. Hi, sorry, the colleagues just got that. Hey Zoe.
Hello.
I just learnt the word Riz with 2 Z's.
What does it mean?
It's like a attracting somebody sort of word. A riz refers to someone's ability to attract a love interest. So a riz might be, for example, I don't know, on Urban Dictionary, how good you are at making friends with new people. Good times. Right, okay. That was the integral that I can't do. What a strange live stream. Let's wait for what's next. Or just do the integral, I guess. Sort of feel like we should do some maths at some point, rather than just making fun of me and my inability to solve problems. Good. Right, cool. The thing about doing a live stream in the office is that I share an office. Right, good, okay. Thesis.pdf is doing really well, but complex numbers has just overtaken it. Should we try and learn some complex numbers? Should we see what we can do? Let's see what we can do. I've tried to do this on Math Club before with mixed results. We'll try and do complex numbers. Come on, chat, you've been talking about complex numbers forever. Let's do some complex numbers. Complex numbers time. Chat loves complex numbers. There's no complex numbers on the mat, so they've been not official for quite a while. I think the really fun thing about complex numbers is trying to work out what effect they have on how functions work, which is really hard to imagine. So you might have like your function might be like f of z equals z squared, which we know an expression for. It's like I is the square root of -1 or something. Oh, we good? We're running? Stop the timer. And trying to work out, so this function, I've written that in a little bit of a strange way. I'm going to slightly change how I've written that. It's not wrong, it's just not in alphabetical order. And sometimes writing things in alphabetical order is helpful. Do I like that? I think I like that slightly more. Okay. Right, good. So, trying to imagine what this actually does, though, involves something a bit strange that's a bit four-dimensional. It's surprisingly hard to work out how these functions actually work. I say four-dimensional because the input is kind of like 2D. You know about the Argand diagram, maybe, where you sort of have x and y living over here, and you can think of your complex numbers as living like points in the x and y space. And then somehow the answers that we're getting out are also complex numbers. So maybe if I call this u, that's the normal thing to call the real part, and if I call v 2xy, then u and v are also sort of the components of this thing, x squared minus y squared plus 2ixy. This is some sort of point in complex number space over there. So something you can do that I think is within your powers to do this is to do something like make a little Desmos thing or something that explores if you change x and y, but you have the point x comma y. So in Desmos, this will give you something that moves around, but then you set, or maybe we'll do the point u comma v in Desmos, but then set u to be x squared minus y squared, and set v to be 2xy, and put sliders on for x and y. I think you can do that, and you can explore how, when you change x and y with the sliders, how does that move around this output point, this point that lives in UV space, point with u's and v's. I think that's possible that you could set that up. You could choose your own function as well. I've gone for z squared, but maybe you could imagine something else like, I don't know, z cubed plus 3 or something. Whatever you want to do. There's a lot of stuff going on here, and a lot of stuff for you to investigate as you move the sliders or change different functions. I could tell you stuff about these, I suppose, but it's sort of almost more fun to imagine you going off and trying out to explore how those points move. Something you might be interested in is if you change the x and y sliders, can you get the points to go all the way around, and are there different ways to achieve that? So sort of a game is to try and get the point to move all the way around, and maybe there's other ways to do that. I mean, in the boring old XY space, it's quite a boring game. Like if you just had x and y sliders and you were moving the point x comma y, then getting it to go round the origin is just like decrease the x slider, decrease the y slider, increase the x slider, increase the y slider, and you got round. And that's basically all you can do. So Yeah, I think this is basic Desmos. Should we have a go at it? Let's have a go at it. Let's have a go. Right, this is now a Desmos live stream. So I don't want sliders for those. I want U to be x squared minus y squared, and I want v to be 2xy. And I want sliders for x. Oh my goodness. Do I have to use different variables because Desmos has reserved x and y? Ah, Desmos, why have you done this? Why have you done this? Okay, right, Desmos. Turns out you need to put different variables. I should not have picked these variables. Right, good, we got there. We got there, okay. There we go. Right, brilliant. So changing x and y changes where that point is in terms of its u's and v's. If you move it, the red point kind of zips around like an asteroid or something. And it's a sort of fun game to work out, can you get it to go all the way around the origin? And there's multiple different strategies, I think. If you're great at Desmos, then you might like to explore this in other ways. But, oh gosh, I think I may have done it now. Being able to describe how do you change the x and y sliders to get this point uv to go all the way around. Okay, there's a sort of game to try at home. I think what you find is that in the xy world, you need to change the sliders quite a bit. Maybe, I don't quite know what the right notation is for this, of how you change those xy sliders. To get the uv point to go around, I don't think you need to change the xy sliders quite as much. I think you can get away with changing them less, whatever that means. And the reason I think trying these things out is a good idea is because this stuff's incredibly hard to visualize. You've got a kind of 2D input and a 2D output. That's 4D. We've got no chance of imagining something in 4D. But if we could get used to that kind of relationship between, think about maybe the inputs as sliders and the outputs as a point in space, that might give us a way to approach it, to change which ones are being plotted and which ones are just abstract sliders. That might give us a way to build some intuition about how these things work. This is functions on complex numbers. Of course, if you've set this up, once you've built this, there's no reason you have to take the real and imaginary parts of a complex function. You can do anything you like, I suppose. But picking the real and imaginary parts of a complex function is quite nice. Those ones are pretty good. They do some good things. Right, okay. My chat has gone weird. Let's read this. It's someone encouraging people to like the other ones. Posts encouraging people to like other posts. Good stuff. Right, okay. And people are trying to develop the strong theory of maths-based chat-up lines. Are you vector calculus because you're difficult to be around? Is gases in binary? Right, okay, great. Good. If you're really great at Desmos, you can get Desmos to plot more than one point at once, or even draw some lines or something. To go, as I was moving that slider, it's moving a point around. I suppose if you're really great at algebra, you can work out equations for those lines in terms of u and v. What I'm doing there is keeping y constant and changing x. So if you squint at these, and if you think about y being a constant but changing x, what does that mean for u and v? How do u and v relate together? There's some math we can do. Sort of want people to have a go at that as well. Other functions, other stuff going on there. A really nice function, if you get the chance, is az plus b over cz plus d, where a, b, c and d are all complex but constants. This is called a Möbius map. I can't pronounce this thing. I have honestly no idea. It is Möbius time. And they're really good. They do some brilliant stuff. It's very tempting for me to just link to a YouTube video that shows you what they do and how they move points around, and we can watch the video like it's Teletubbies. But I think it's more fun if you try and explore it yourself. That's a lot of work, by the way, because there's 4 different letters there, So that's extra sliders in Desmos or extra things to try varying. They're complex numbers. So when you try and write down the real and imaginary parts, you've got to do actually quite a lot of work. Maybe start with them being real first. And write down maybe real and imaginary parts and then try exploring. Using the tools that you've got to try and crack into understanding what these things do. And then when you get bored of that, stick it in YouTube or something and watch a video. I just feel like people over here watching this one have a good chance of, not just watching YouTube videos. There are loads of great YouTube videos out there. This is not one of them. There are loads of great YouTube videos out there. But I think you have a chance of exploring things for yourself first. What is Z in this case? Z is the input. So this is f of z is this, where z is, you could write it as x plus iy if you want to. But normally when people are talking about functions on complex numbers, they just write them in terms of z, z representing x plus iy. Yeah, okay, z is that. The duality. Yeah, sorry, it's not a. Yeah, sorry. You can't. Okay, so I'm sorry I put a z squared down, and I'm sorry there are squares everywhere. I'm sorry if that's. Oh no. Oh no, I thought we got pretty far away. It's 6 o'clock, thanks to the hydration check. Hydration check approved? Halfway point, Prisma's doing great. Prisma's doing extremely well. Prisma has done about twice as much comment moderation as normal. If it's your first time seeing the live stream, we've got Prisma, who's a current student. They're working extraordinarily hard right now to moderate chat to make sure that we're not dividing by zero. Opinions on the Riemann course. What course do I lecture? I teach tutorials at Oxford. I do some small group teaching in applied mathematics. Okay. Am I going to answer the question? Please don't spam physics. Do I have a drink with undergrads, like a beer or even shots? They haven't invited me. No, that's a lie. They did invite me out, but I was busy. Anonymous asks about the flask. The flask is a water bottle. It's way too big. It keeps falling out. I keep dropping it. It makes a loud clanging noise whenever I drop it. If you're going to get a water bottle, either don't get a metal one or don't get a huge one that you're going to drop a lot. I've dropped it loads. Look at that clumsy. My goodness. I've put a sticker on it. The sticker has a bigger fan following than really thought so. Hydration check is a regular thing, which we do every week now. Can I reject a rejection letter? Give it a go. Give it a go. I feel like I've seen this. I don't really want to do a Matt Thoughts poll because I'm trying not to talk about it. I did show the sticker. I'm not shy. Sticker is a great wave. It's amazing. I had it on out of it and then almost immediately chipped it slightly at the bottom, and that's going to annoy me for everyone. Good. Okay. What are we doing? So there's complex numbers. Should we do a bit more complex number? I sort of quite like complex numbers. I want to do De Moivre just because it's amazing. Sometimes these things are better if you write them in terms of polar coordinates. We did polar coordinates on the maths club a few months ago, and it was a bit of a disaster. Nobody knew about polar coordinates. Let's do a quick vote. People like interaction, right? It's a multiple. It's going to be a multiple choice vote. There are only going to be two options. The options are just going to be yes and no, and the question is just polar coordinates ? Which I don't want to talk about them. I talked about them a few months ago, and no one was ready for it. Nobody wanted to hear about polar coordinates. So I need some sort of, I guess, consent. Free revision. Let's go. Polar coordinates interact with complex numbers in a nice way, so it feels like mentioning them now is a bit irresistible. I have a way to make polar coordinates really weird, but I've had worse. Somebody asked me how I feel about people saying that was bad, and honestly, it really hurts me because 13 weeks. We've been doing all this map preparation. We've been doing great stuff. And then with the other hand, it's like give with one hand and take away. I have to write these map questions that shortlist people down because we've got more applicants than places. So I have to write this. Prisma, if you can hear this, you need to ignore all of the people asking you for personal statements. I would strongly advise you not to put your personal statement on the internet. Someone else, does everyone find their personal statement embarrassing? No, but everyone finds my personal statement embarrassing. Seriously, my friends have seen that video, and my friends all agree that that video is bad. Zoe in the office has seen my personal statement video, agrees that it's pretty bad. Yeah. You just saw it now?
Yeah.
You didn't know about it before?
I sat through the live stream. I watched it.
Zoe's watching the live stream.
I saved the best comments. I'm going to send them to you.
Great. So I always love it when, I don't know if you heard that, so Zoe in my office has not previously been in the live stream, but has been watching this live stream. Their chat is excited about the idea that Zoe's in the building. There you go. You're famous. Zoe runs the ambassador program for people who are here, so
Yes.
and also runs outreach stuff. Right, good. Okay.
And
Oh, they did hear you say the phrase "sat through the live stream," which they've described as hesitant. Hi, everyone else who's sitting through the live stream. See you around, Zoe. The chaos is here. Is it Zoe who sends the outreach email? Yes. Zoe's gone. Right. Okay. Okay, we're doing polar coordinates. That's happening. Brief distraction by Zoe's gone. We're not getting Zoe's honest opinion. There we go. Right. Good. Chat say hi, Zoe. But Zoe's just left. Zoe also sends the outreach emails. If you sign up to find out outreach emails, then you get notifications from Zoe. Zoe's not watching the live stream anymore, so I can say Zoe is extremely organised. That's the only reason that stuff actually gets done. Yeah. So polar coordinates work like this. You would normally write you'd normally write x is r cos theta and y equals r sine theta. As it's sort of a substitution, that's not a helpful thing to say. It's sort of a change of variables, that's not a helpful thing to say. It's sort of some rules. R is the radius that you're familiar with, and theta takes a little bit of getting used to. It's the angle above the x-axis. But this gives you a new way to describe where points are. The old way, Cartesian, with x and y coordinates, just says how far across you go and up you go. That's where things are in terms of x and y. Whereas r theta gives you a new way of describing it, which says go around by an angle theta and then go out from the origin a distance r. And this has got some advantages. You only need to talk about numbers theta between 0 and 2 pi. R is just a positive number, so in some sense it's a little bit more limited. And they're really, really good for describing things that scale up and for describing rotations. So if you have a point xy and you want to describe how it's been rotated about the origin by some angle, you don't even do that in A level really until you learn about matrices or something really late on. But if you've got its r and theta values, if you're storing these, then to rotate that point around the origin, you just need to change theta a little bit. So if you were keeping track of it by remembering r and theta on two different sides of your head, r and theta for where the position was, then if you want to rotate it around the origin, you just update theta a bit. And that's a good way of keeping track of where stuff is. It does feel a bit like parametric equations, doesn't it? You can think about these, if r is fixed, then this is the parametric equation for a circle, which you might have seen. And that kind of makes sense. That's like describing all the rotations. So you take your point and you can rotate it around by changing theta, and you get a circle. That's kind of how circles work. It's one point rotated around the origin at some fixed radius. There's this other thing you can do, which is, I guess, I'm going to say it, it's not very helpful. If theta is fixed, but you change r, then this is a parametric equation for half a line, which is sometimes called a ray. So if theta's fixed, then you just get these points. changing r between 0 and I guess r is between 0 and infinity or something. Theta between 0 and 2 pi. Other choices are available. Oh, what are parametric equations? Kai, parametric equations are great. If somebody shows you x and y, but both x and y are a function of something else, classic choice is t for time, but it doesn't have to be. It could be a function of whatever you like. And then as you change t, x and y will both change and move around, and you could keep track of how a point in space moves around as you change x and y. You can use these to describe a thing moving in circular motion, or to describe a curve in space that might not work like a function, which might not be set up well to be described as a function y of x, but maybe you could describe it in terms of x and y both changing with time. Okay. Do penguins use polar coordinates? They should. Penguins should be taught polar coordinates. Okay. So straight lines polar lily, asks Jay. Yeah, so straight lines have got this advantage that they're really nice in terms of x and y coordinates. You know, you've got this y equals mx plus c. We've actually learned quite a lot of different ways to write equations for straight lines across many different formats of different bits of live streams and flashcards and things. We also had things that look like this, x minus x1. Or sometimes I've been writing things like mx minus x1 plus y1 for the equation line, which is the same thing but moving on the right hand side. Jay's asked how you do straight lines with polar coordinates, and it's a little bit messy, but it's not that bad. I'm going to draw some axes so that you can see where I'm drawing things. Although drawing the axes is a very Cartesian way of looking at the world. Really, maybe I should draw some circles. Never mind. Let's say you've got a line like this that you would like to describe. In x and y, that's easy. You just write down, find the gradient, write down y equals mx plus c. In terms of polar coordinates, something you can do, you have to do a tiny bit of geometry. If I drop a perpendicular from the origin to that line, polar coordinates all about the origin. If you're doing a polar coordinate problem, put the origin in. If I drop a perpendicular from the origin down to that line, then I can see that any point on this line, wherever it is going to have, well, this angle, I'm not going to call it theta, I'm going to call it something else, phi, is related to this radius, the distance is related to the angle by some sort of trigonometry thing, right? The line's fixed, this distance down here is fixed. So if you drop that perpendicular and measure it, to find this distance d, that's fixed, it's just a fact about your line. How far away is it from the origin and its closest point? And then every other point on the line is going to have something like adjacent over hypotenuse is cosine. So this is like r cos phi is equal to d. Think about this right angle triangle. So that's a relationship between r and phi, which says something like r is equal to d divided by cos phi. Now, of course, that's not quite a relationship between phi and theta, because there's also this bit of angle which says where's your line, how much has it been rotated by. So really what I want is theta is equal to phi plus a little bit for some extra rotation around. So my final expression then is to write cos of theta minus alpha in here. That's a straight line, which is a bit of a weird expression. It's divided by cosine. It's sort of super weird. It blows up to infinity quite at a couple of places, which is a bit maybe odd behaviour. It goes negative for a bit, which is even weirder. But somehow this is the description of a straight line in polar coordinates. So it looks a bit nastier. There's random straight lines not so good in polar coordinates. Oh look, sine theta plus cos theta. Oh yeah, I think that's equivalent to multiplying out this. Alfie? Yeah, cool, okay. Yeah, brilliant, good question. Polar coordinates are sort of brilliantly linked to complex numbers, because there's this great relationship that if you define if you define e to the I theta to be equal to cos theta plus I sine theta, that gives you a nice link, and lots of things work nicely if you do that. It's not just a mad definition. Let me show you one of them really quick. No, you can't differentiate cos and sine. Both sides match up when theta is 0. Maybe that's not a great fact, but they're both equal to 1 when theta is 0. And once you learn to differentiate both sides, they kind of match up under differentiation, so they're pretty nice after that. So this is quite nice. If you do that, then it gives you this really nice link that r e to the I theta would be equal to r cos theta plus I r sine theta, which is just x plus iy, which is what people, those are the components of our variable z. So this gives us a new expression for complex numbers. We could write them as r multiplied by exponential of I times theta. I'm not claiming to have a good answer for what does e to the power of a complex number mean, or how does it relate to the real exponentials that we know and love. But somehow this gives us a new way of talking about complex numbers. The radius, how far away they are from the origin, multiplied by exponential of I times theta. Okay, this is pretty weird, really, and it exposes a lot of weirdness about theta. Up here, it claims that you need to take theta between 0 and 2 pi. That's not quite true. You can change your range of theta. There's this slightly odd thing: angle above the axis. Angle above the x-axis, maybe you start at 0 and you go all the way around, you get around to 2 pi, you get back around to the same point again. Or said differently, I'm going to write down these slightly, not quite the facts that you want me to write down. The e to the 2i pi going all the way around, so this is what it means. R is 1, the radius is 1, and theta is 2 pi all the way around. That's all the way around the circle. We got back to where we started. That's the number 1. This is a bit weird and has some other stuff. Josh wants to know how differentiation works. Yeah, same. It's a constant. So you would differentiate, if you want to differentiate this left-hand side, you get e to the I times e to the I theta. Just like how we've been writing out stuff with k's in for differentiating e to the k theta all the way through term. Yeah, it's fine. Yeah, so you can do instead, and some people do this. So this is what I was taught in school, I think, but there is an alternative, and that's to take 0 between r and infinity. I actually really hate it when people write less than sign, infinity sign, but hey, here I am. Theta between minus, I should have put one of these equal, gosh, theta between, not that one, maybe that one. Yeah, it might be that one. Yeah, feeling that one right now. There we go. There's also this alternative, which is to choose a slightly different range for your thetas, and nothing goes wrong, or nothing new goes wrong. You've just picked different angles, which has then got sort of a weird philosophical meaning, because you're still describing the same points, but you're using different ranges of the thing to describe them. So that's a bit odd. I promised you some sort of link between this and the functions we were just doing, and it's coming. The thing is that really you could think about r and theta as being input variables, and x and y being output variables of some sort of complicated function that's going on over here. So r and theta go in, and then they give you x and y points. We can imagine doing the Desmos slider thing, but with x and y being the point moving around, and r and theta being the secret behind the scenes things that are changing. I don't know the history of sine and cos. This is a comment in chat. Who invented the function sine and cos? I don't actually know what the history is there. Okay. Let's try and delve into how that function would work. R and theta going in, x and y coming out. So this would say that behind the scenes, does some sort of r and theta world where the things on the axis are r and theta. They vary, and then as we move around in here, that gives us different points, x and y. And in order to describe all the points, we can just take r being positive and theta being between 0 and 2 pi. This region of space. So somehow this region of space in r and theta world, picking a point inside here and moving it around, describes everything in the x and y planes. So it's just a limited bit of the r and theta space describes everything that's going on in the x and y world. So now the question is, what does the rest of it describe? And this is related to sine and cosine inverses, which Physics Girl has just mentioned in chat. What does the rest of it mean? I'm letting chat catch up as well. We're also suggesting fun things to do on stream in chat. So here's one thing that we could think about. The alternative choice that we had was to take our region of space and think about a description of all space being between theta between minus pi and pi, and that overlaps with this region, but it also includes some stuff down here which represents the same stuff as up here. So another one down here, these points down here with theta between 0 and minus 2 pi, this is another copy of reality. So that's pretty good. This says that these points down here, where theta is negative pi, they've just rotated around. Let's try and do this the right way around on screen. They've just rotated around until you've got all the way, that's the wrong way, isn't it? They've rotated it all the way around and then kept going, but they're still describing points in x and y that happen to be the same points. The same sort of copy, there's another copy of the x and y points. So we're not exploring a different reality, this is just a different description. And then the alternative choice that we had up there was to take kind of half of that pink world and half of that alternative reality world, and nothing actually goes wrong. They kind of match up they match up perfectly and seamlessly, so that choosing which one you're doing is to go through. What's the worst thing you've seen in maths? During a maths interview, I was being interviewed, I had 5 to the power of 4 divided by 6 to the power of 4, and like a chump, I tried to simplify it by cancelling out the 4s. That's probably the worst thing I've seen in maths, and it was me doing it. Okay, we've got this another copy of reality that we've discovered just underneath this pink slice. So we've got more over there as well. We're also playing a game to explore what the limits are of people's chat up lines. That's not a real game, that's not an invitation in chat. There are more stacked copies up here. This is quite a strange headspace, I suppose. Because I'm taking r and theta, I'm trying to completely separate them from their geometrical meaning. I'm just thinking about them as variables over here. When I've done this with university students, they've found it... Oh, by the way, spoilers, I did this with university students. When I've done this with university students, they've found it, I think, mostly confusing because they've got strong feelings about r and theta. That theta means angles. Whenever you see Greek letters, angles. R means radius, means geometry problem. So maybe people would be happier, I don't really know, if we switched these out for different letters, and I put different letters matching up over here. So they were just thinking about input variables, and thinking about changing those variables. Like when Kai was talking about parametric equations, and we were thinking about just changing one of them as a variable. It kind of is nice to use theta because it means angle, and it matches up with all the stuff we do in geometry. We don't have to use theta, we can use t for time, or something else. Okay, ooh, why's that appeared at the top? Oh, no, we're good. Sorry for shaking the screen. The other copies of reality. The really interesting thing is what's going on the left for negative r. Negative r is super weird. I think, and you should try and check this and explore for yourself, but but I think there's other copies of reality over here that also correspond to all the points in XY space, but shifted out of step on the left, so that the blue stuff over here is another perfectly good description of all the points. Do I mean out of step? Sort of, I suppose. I guess nothing really goes wrong. No, I feel like that's a good structure. I feel like that's a good way of thinking about it. Anyway, I'm not being entirely clear about what a slice of reality means or anything like that. The lines all correspond to the same cut, the same ray in space. These are all the different. Let's be precise. For the people watching at home who would like me to be more precise, the vertical axis corresponds to the pre-image of the origin, and the horizontal lines are the pre-images of a ray along the positive x-axis. The question is to find all of the pre-images, and they lie at interesting points, I claim, in the r theta space. Okay, that's the end of the precise bit. It keeps repeating. Yeah, it keeps stacking up. There are lots of these other ones. So they're moving around. This is a way to describe. So let's imagine a little point. Desmos only lets you do 1D sliders. If we had 2D sliders, we could imagine moving a point around in our 2D sliders. As we move upwards to change the values of r and theta, if I move upwards, then I'm just changing theta, and that's like spinning around, it's like rotating. So this up and down motion would be, in r theta space, it's just going up and down, but the x and y coordinates would be spinning around, rotating. So this is doing rotations. R moving like this is moving in and out of the origin in the xy world. And somehow I have to try and square that together so that this is an entire rotation, because I've gone into one of those other parallel reality pre-images. This is a whole rotation, and this is half a rotation. I guess, backwards. Okay. And then trying to get your mind to the point where you can understand what this means is a real challenge that I don't think I've quite done. Of what it means to cross that line and then cross that line to get back again, going through r equals 0. I guess r equals 0 means the origin, so this is like moving through the origin, out the other side, exploring a bit, and then coming back again through the origin. Good stuff. Okay, if you can do that, then you can start imagining things like r equals cos theta, but expressed in terms of polar coordinates. Good, okay. What happens if you move the point on a quadratic or a line? Other stuff. I don't know. Where do you want the quadratic to be? I'm moving it along a quadratic, moving this point. So I move this point. So I change r and theta at the same time. Good question. I guess it rotates and scales outwards. You could sort of program that. I think Desmos is going to let you down by not having two-dimensional sliders. But you could sort of explain where you want the point to be over time. And then as time is changing, time is a 1D slider. Don't clip that. Time is a 1D slider that you could put into Desmos. So you could. This is a bit mad. This will look horrible, but this is my plan for how you would explore this in Desmos. If you don't care about Desmos, then ignore this bit. I would write down r of t and theta of t, and then I would work out x of t is equal to r of t sine theta of t as functions of time. I would work those out for whatever you want to do, line, quadratic, whatever you want to do to explore, move this kind of pointer around in r theta space. Do whatever you want, but then calculate x of t and y of t and just plot it in Desmos. Okay. Sorry to repeat, says someone. Out of step with the same as in the step. Oh yeah, it is. Yeah, and I pause because it does repeat on the left as well. It's sort of in step, except these points on the left don't correspond to the same stuff as the points on the right. There's a subtle difference. Negative r is kind of different from positive r. You get different points. There's the same behaviour over on the left. You're right. It does repeat again and again on the left. But these points feel more like these points to me than they do like these points. I'm not being very clear. This is the pre-image thing, but the points you get when you apply r and theta, if you're on one of my solid lines, then you always get the same points in the xy world, whereas that dotty line gives you different points. Oh, what's that? Okay, good. I've grabbed it now. I quite like it. Okay, quadratic of theta in terms of r. How does that affect the xy ones? Give it a go. Is this a true fact? The Vice President of Warwick Maths Stock is also called James Monroe. Do I need to try and meet this person? Is that a joke or is that a real thing? Hi, if you're watching this and your name is James Monroe and you're the Vice President of the Warwick Maths Society, say hello, get in touch. You've got my email address. Right, good, okay. What are we doing? It's 6:30. We've got half an hour. We've still got, amazingly, some viewers. Finding out our complex numbers and polar coordinates. Good stuff. Somebody says true, and I'm not entirely sure if Joe is telling me that the previous fact was true or trying to describe something else. Good, right, okay, we'll find out. I might be adding to the list of James Monroes that I'm aware of. There are several of us. I'm too scared to admit that I don't know how Kahoot works. Making learning awesome. Do I have to build a quiz? You don't want me to build a quiz. Come on, chat. You don't want me to build a quiz. You really don't. The whole hour and a half so far has been how cross you are with me for building a quiz. I'm out of town, unfortunately. Yeah, nobody wants my quiz. Right, good. Okay. Was there a daylight savings change? Oh yes, gosh. So I normally try and put a reminder up about daylight savings time. Was it last week? Sorry, international people. We do this thing where we change all our clocks. These days, most of my clocks change automatically, so that's a bit different. Poll for Matt. Okay, right. I will level with people. New poll. The options are yes and no, and the question is just talk about math for half an hour. And if no wins, then we will talk about graph theory or something else. If yes wins, then we will talk about some of the math questions, I guess. International people are very disgruntled. I am international people. Someone says, hey, look, you're three likes for can we do a math poll, and now it's happening. Look, you've had a direct influence on some Oxford content. Oh, this looks quite nice if you zoom out. I'm pleased with that. Colour scheme. Carl Frederick Grouse behind the scenes thinks that I'm winning the James Monroe competition, but there again, Google does know what you search for. Okay, we're talking about Matt for half an hour? Matt for half an hour, okay. Gonna give it a little bit of time. Democracy, isn't it? This is how we lose viewers as well. Unfortunately, not a boson doesn't want to talk about the exam. The problem is, when I talk about the test, I talk about it quite differently to how you talk about the test. I want to talk about things like Pell's equation and Brahmatra's identity, but I don't think anybody else does too. Right, okay, let's give it a go. Let's give it a go. Pick a question, chat. What are we doing? Q1, Q2, Q3, Q4, Q5, Q6. I'll try and make it fun as well. I'll try and make it fun. It's as fun as we can together make this. My interview error has no disclaimer next to it. Oh yeah, there's no disclaimer. This is just some fact that's in some Oxford content. This is like not advised. There you go. You can try this move, but nobody wants to. What happened to Q12? Hey, someone says what happened to your Twitter account? And they've noticed that I've deleted Twitter. Didn't think anyone would notice if I deleted Twitter. Question 2 and 4 look like step 1. Step 1's not a thing anymore. You see, that's the sort of fact. You're not alone in thinking it was a disaster. Q2 is winning that vote by a long way. Okay, QT. Here's how QT works. So Q2 is about generating solutions, right? So we said that if x squared take away 19y squared is equal to z, if it's equal to some number, then I think we put it like this, didn't we? X squared minus, I think we called this n, y squared squared, take away 19, 2xy is equal to z squared. and I guess if big N is 19. So this part of the question was trying to get you to notice that it's z and z squared. And I sort of hoped that you would square this expression to get something as a squared in here. Square this expression and compare coefficients and try and work it out. So it's trying to get, it's 2xy squared, yeah. But then the understanding based part is whether you can spot why that's interesting or why that's good. The next part of the question gives you a bit more of a prompt along that way by asking you if x is 13 and y equals, oh gosh, can't remember my numbers anymore. Is it 9? X squared plus n y squared. Okay. Maybe I should look at the question. Thought I'd do a fun thing where I just try and do question 2 from memory. Fun for me, maybe, not fun for anyone else. Which I am learning are very different things, don't worry. It is plus. Okay. Why was 3 for the next part of the question? So then the question really gets in here. It says find, actually it says hence find, pair of whole numbers with x squared minus 19 y squared equals 4. And the hence is important. The idea is supposed to be that you realise that if you squint at this thing up here, that this thing is a number, this thing is a number, and they are examples of numbers that do thing squared minus 19 thing squared, other thing, is z squared, a square of the previous thing. And we had z is minus 2, this 4, you're supposed to notice is, aha, z squared. I'm circling a lot of things. And if you don't spot that link, then I think you get stuck. And that's good for you. Life's not smooth sailing, especially maths. Getting stuck is just normal. And probably I've done this much faster than you would have done in an exam, because I have this advantage that I wrote this question. What I was, I suppose, hoping is that if you got stuck on this bit, you would look back at what was just going on. It's the only stuff we've got so far. We've got a z. We've got an example where x squared minus 19 y squared is minus 2. How can we hence do anything with this information? We've got 13 minus 19 times 9. It's just some numbers, right? How can we hence do anything at all? But yeah, okay, so it took a while to spot it, but eventually got it. So this is what I'm hoping, that eventually you can spot there was some point to this. This was not pointless. Trademark. That you could plug numbers back in here. And that idea, what I wanted the rest of the questions to do was strongly reward you for having that idea, that this let you generate things from having some x and y, gives you a z, but then we can make it z squared, but bigger numbers, to generate this. Most of the rest of the marks, or most of the rest of the parts of the question, let's say, most of the rest of the parts of the question were trying to get you, or just trying to reward you for having that idea. So there's sort of a big barrier in here. You're supposed to get stuck quite quickly, which is why I think people really hate this question, if I'm going by anything. You get stuck really quickly on part 2. And it's question 2, so it's the first long question people look at, I suppose. And you get stuck on part 2 because what on earth is the link? But the idea is supposed to be, once you've spotted that link, it's not so bad for the rest of the question. So there's not very much I can tell you now that makes you feel better. Like if you spotted the link, then hopefully you got some stuff together. You got some progress with this question. If you didn't spot the link, then there's not much I can do to make you feel better, other than to say maybe you can see it now, or maybe you would have spotted it with more time. This doesn't mean that you're bad at maths. If you added the numbers wrong, I think we're going to be nice. How many marks? No comment at the moment. We'll do the detail mark scheme after we've done when we do the mark scheme. Everyone thinks they're pressed for time in this exam. It's one of the things about this. What am I expecting mu2 to be? Oh, I've no idea, sorry. I'm really bad at guessing what the average score is going to be. People got me to do it on a previous live stream once, I think, and it was embarrassing. Try to solve a new y already squared it and wrote down 64 squared. Here, I think, so when we're marking it, there's going to be probably some accuracy marks along the way for getting numbers that work. But the thing that's really interesting to me about marking this question is going to be to look at what stuff did people write down when they're stuck. Did they get close to spotting that they could reuse a previous part of the question? Anyway, the actual next part of the question is to say once we get this big example with big even numbers, and it says hence again. Is it 340 here? 340, excuse me, and 78 here. We get this big example. The numbers are even. I don't think anyone goes around writing down numbers and saying, "Aha, even numbers." But what we really want next is a solution with 1 on the right-hand side. And it says hence, which could mean anything, right? It could mean do it again. It could mean, so we could generate a new solution that has 16 on the right-hand side by running this again. 4 squared is 16, so we could generate a new solution like that. But what we could actually do is divide both sides by 4, and that is hard to spot, or hard to see the relationship between 4 and 1. It's a kind of a different thing to the previous part of the question. If you added the numbers wrong, I guess we're doing error carried forwards, I think. So if you calculated some addition wrong, you should maybe lose a mark for getting the addition wrong, but maybe not lose the other mark. We will see. That's called error carried forwards. Okay. Later part of the question does a thing that I quite like to do in questions, which do it again. I quite like doing this with 17 instead of 19 and no help. So along the way there's been some sort of helpy bits that we gave you a value of x and y. Believe it or not, this counts as helping to find z and then square it and do the stuff. The last part of the question is to do the whole thing again but with 17s instead of 19s, which doesn't change very much except it changes all the numbers but none of the ideas. So again, it's trying to reward you for having the ideas, for getting through. 78. Oh yeah, I posted a video with the 22 paper's up. It's online. 22 paper is up. I've got it in another tab. I don't know why I'm not putting it on the screen. I thought it'd be a maybe traumatic thing to see, perhaps. So that's actually up on the MAT website. If you go to the Oxford MAT website, Oxford Maths website, which is very similar to the URL at the bottom of the screen, but /r/MAT at the end rather than /MATLive. That's got some stuff in. We threw in a part 4 or something. This question's got a part 4, which is sort of a distraction along the way to say that something with 25 instead of, if you put 25 in instead of 19, there are no solutions or no interesting solutions, and then it hits you with the 17s instead of 19s. This is an ancient method for solving equations like this. Let me try and find it on Wikipedia. Yeah, I'm not going to be able to pronounce this, but maybe I can. So, where did I find this? So, Pell's equation on Wikipedia has got lots of these solutions to solving things. Let's zoom in a little bit. Pell's equation is equations of this form. There's a mathematician called Brahmagupta who did a lot of work on these absolutely ages ago, including stuff like this method. This identity that you've used as a form of Brahmagupta's identity. And there's some techniques for solving these things in general. There are some competitions in the 1700s between mathematicians to try and solve these. Some of them have got implausibly large solutions. Pulling out this table somewhere, where have we got? What have we got in here? So with 17, there's the one in the MAT question. With 19, there's the numbers in the first bit of the MAT question, 170 and 39. But sometimes for like 109, we're glad it wasn't 109 at the end of the MAT question because the numbers are just huge. Sometimes the solutions are weirdly large. This is the equations. The thing in the question is linked to some surprisingly complicated mathematics. I'm trying to solve this for other ones. Dashes here mean there's no solutions, which happens whenever it's square, which is something proved in part 4 of this question. So I don't really know. Look, 13's great. 13's got these massive numbers. This is the smallest non-trivial solution, I think. Good. Okay. Pell's equation. Somebody in chat asked me if I knew what Pell's equation was earlier, which is good fun. Yeah, okay. We're being asked to give error carried forwards, which is something we do. Policy often gets developed when the marking team assembled. What font are the paper in? The font is in something called Computer Modern. Computer Modern is the default font in a system preparation system called LaTeX. It's a fancy way to write it that I can't do. But anyway, LaTeX it's pronounced k at the end. It's like a chi Greek letter. It's a fancy name. LaTeX is this document preparation system that makes pretty maths documents. The font's called Computer Modern. Thanks for asking. Can I send the PDF? It's not on the website. I think it is. It's not on the... It's on this website. This is my website. This is where people find out about the live stream, right? The one with the cup on? If you haven't seen this website, then I've really, I've let you down. This is my Matt website, which has got on flashcards, and this is where we are, and this old video that I made, and then way down here, table of past papers, with solutions and feedback and histograms and stuff, and Mewtwo that people are talking about. When people say Mewtwo in chat, it's not Pokemon, it's that table. It's a Matt website, /r/Matt. How long does it take to market? We're going to spend I've got about a team of about 100 people spending about a week and a half. Right, okay. Yes, guys, we're still amazing at maths and we're going to rule the world someday. This is the thing. You absolutely are. Not everyone's going to study at Oxford, but you're absolutely going to own it. I give it about 5 years before my generation, we're just out of here, and you're in charge of absolutely everything. Is it unfair because Olympiad people will know this stuff? Olympiad people know a lot of stuff. It's really hard to write questions that Olympiad people know nothing about. They tend to not know extra stuff about integration, which is question 3. But it's just in general really hard to write questions that Olympiad people can't do. So I tend to not worry about this too much. Question 5, 13, 11. What does the 13 and 11 mean in that one? Question 5, no, wait, part numbers? No, I don't know what the 13 and 11 means. Raphael's linked to the paper, and so is an anonymous person. Thanks, chat. I think it is cool. Who marks the papers? I get a team of about 100 graduate students. I pay them to mark papers. They take it extremely seriously, because of course they do. Lots of them took the MAT themselves, so they know that it's important to you, and they're really nice. They're also extraordinarily good at maths, so they if you've written something a little bit unexpected but true, then they will love to see it. Good, okay. What shape did the graph tend to in the limit? Oh, is it question 3? Question 3 is a bit weird. No, wait, the graph in the limit. What is that one? Is that 4 or 3? 3's got a graph and a limit. They're just raw answers are on the video. I'm going to be penalised for saying this. This is why I don't totally love talking about the questions now, because I haven't got my team of markers with me. Penalised that we didn't consider the negative numbers. I think you'll probably be okay, but maybe I shouldn't say this. How much weight is placed on getting an answer to the n = 17? You can definitely get, so this one is going to be worth quite a few marks, I think, at the bottom. Not loads of marks, but some for part 5. And we're definitely giving marks for ideas along the way. So getting a number that works is great. It means you've done enough to get the marks. But having some scribbles or having some working out without getting down to a solid answer, I think will still get you some marks. Oh, gas is being used this year. Reset the paper now. Oh, it's Ornum Semaj. Love that guy. He's like the opposite of me, so let's quickly work out what the opposite of me would be. We've all thought of the jokes, there we go. Oh, is everyone looking at the past papers page? Wait, there's a separate past papers page. Oh, this is sort of unmaintained. I know exactly what you mean though. You're looking at... yeah, point taken. You're right, we have a separate page. We have a separate page that looks like this, which mirrors that table, but has not been updated. Thank you, chat, you're not mad. I'm sorry I gaslighted you by saying it was on the website when you were looking at my website. This will get updated, probably tomorrow morning. sorry that you've been looking at this page. This is good for me to know that people look at this page. I think it maybe comes up if you Google Matt past papers. It's technically a separate page that needs to be updated separately, and we keep forgetting. Right, good. Okay, you need to go back up one level to get to the teacup, and then it was in that table. They used to be linked. Okay, let's do a quick website. We've got 10 minutes. We got a quick website sidetrack. Those two pages used to be linked. They used to mirror, so that if one updated, the other one updated. And this was really nice because it meant that the table was halfway down that bigger map page. But also, people could just look at just the table separately on its own page. And I saw that some external websites were linking to just the table of past papers. That's nice, right? You've got this list of past papers, and actually some of you in chat were coming up, first page on Google search, right? Okay, it's a really important separate page. But then our website migrated. On the new website, they are not linked. The link is broken. The connection between the two is broken. So now we have to remember that they're different. That's the hard bit. Updating both of them separately, it's fine, it's an easy job, but remembering that you have to do that now is the hard bit. There's something about life in there. Do you think I get any credit on 5 for writing 4 squared minus 17 times 1 squared? Sounds good to me as -1. But using generating formula for 19 instead of 17, oops. I think you'll probably get it. Yeah, you'll probably get a small numbers mark. You get a small numbers mark. If the marker is looking very closely, they will notice that you wrote 19 instead of 17. There's 1 or 2. So I like 1 or 2. Tamua takes microseconds to mark because it's all with computers, whereas ours is all with humans. No comment. I think I'm not gonna. First page on Google search. Tamua is multiple choice. Right. Yeah. So Matt takes a bit of time. Anonymous person. How are interviews going to work? Do you want to talk about interviews? We've got a live stream about interviews. It's coming up in about about a month, I suppose. Let's do a really quick bit about interviews. An interview question I've been using recently, but not anymore, is when is x to the 5 plus ax cubed? Have I already talked about this one? Does bx an increasing function? And I like it because it's about differentiation, it's about solving quadratics, spotting a hidden quadratic, and doing extra bits and pieces. People usually make some sort of mistake, but it's okay in an interview to make mistakes because the interviewer is there to help you out and to try and get things going. Interviews are going to work like this. We're going to do them online, so people will be at home or in school or somewhere quiet to do an interview. Maths is going to be using Miro whiteboards, which people can join in with. If you've got something that writes with a tablet or something, then that's great. If not, Oxford is currently investigating whether we can send something to you. If we shortlist you for interview, whether we can send something to your school or to your house. If we shortlist you, maybe, if we need to. We're currently doing the budget. It's not my money. It's not my money, so I shouldn't giggle, but that's currently being budgeted, so please don't panic. We've done this a couple of times before. People are going to write on that, so that it's like being in one of these Miro boards, but you can write as well. Plus video call, hoping that we can get video calls to work again. Good. Cambridge is doing a lot of different things. I think Cambridge is not fully online. Cambridge is doing some online things and some in-person things. We will see. Anyway, this question is quite fun because increasing means that it's going up, so you get stuff differentiating. Would I get a few marks for creating a new formula for n equals 17 for part 5 of question 2, but then I didn't know what to do? 2 things to say to this. I think there's a good opportunity for me to say something important. Yeah, you're definitely going to get marks, I think, for doing some maths. More importantly, you did some maths. You should be really proud of doing the maths. You did what I would say is the hard bit, inventing a new function with the 17s in, and to take the first part and to adapt it. To make something new. If you can do that, then I personally think that you'll do just really well in the rest of your A levels or whatever, and in university maths. If you've got that kind of spark to take a thing you've seen and adapt it and invent something new. That's the main thing that I like about question 2, is to do it again, but with twist, which is the bit that you did. Okay, you didn't guess some small numbers and then apply your new formula. But you've done in some sense the hard bit. Now, whether or not you get any marks, whether or not you go to Cambridge, Imperial, Warwick, Oxford, wherever you've applied to, doesn't matter. You're still you, and you've done a cool thing. Negative feedback to Matt is similar to previous years. Yes. If anything, I've got fewer hate emails than I did last year, and certainly than 2 years ago. So maybe the internet's got much nicer, or maybe this one was about okay. Good. Is there a chance of getting an interview with Matt score of 40? Yeah. Yeah, I never say never. If you look at the past histograms, we've interviewed people with Matt scores round about there before. James, when you write on Miro, do you use a stylus and pen or a mouse? I have a very cheap graphics tablet. Not a lot. Sorry, I said that like it was for sympathy. This is critical for me to know. So shine is a bad start, right? Because I'm one of those people who says shine. But then I try to be consistent, so I say chos if I remember, and fan and shek, chosek and chot. But you know, I'm never quite that. Never quite remember. Yeah. So shine, chos, fan, and then the other three. Oh, that was not what Gonzalo wanted to hear. Right. Okay. You can't. Email's free. If I remember, people in chat are not happy about Charles and Chart. 2 years time. This is James in the future. Which side is he on? He's on that side probably, unless he's changed his live stream setup. Nah, he's lazy. He'll never change his live stream setup. Yeah, sorry. Don't forget to say Charles. Right, cool. Talking to future myself. It's also ego thing, right? Because talking to future myself means that I turn my face up to the heavens. It's like, hi, future James. God, dearie me. Did I say something about being too confident? If you fail your A-levels to do really well on the maths, never say never. You're not going to fail your A-levels, by the way. You're really not going to fail your A-levels. I can tell, because you're at a maths club. Good. I also do get emails that are not hate emails. This is not me begging for nice emails. I get enough nice emails, enough as it is. And enough normal emails. This has got weird. I was telling someone something important about A-levels. You're not going to fail. We have sometimes taken people who slightly missed their A-levels, especially if there was a good reason. If you have a good reason, then let's do your best. But free school meals, we've finally got detailed information about free school meals. You get put, if you're personally eligible for free school meals, we have this on an individual level now. You get put in. We have some sort of. How much do you want to know? There's a marker in the database. All the tutors are very aware of this, as we think it's the best metric we've got for indicators of socioeconomic stuff. Compared to all the other indicators we've got, free school meals is the, we think, best measure because it's candidate level. So much so that we've put a kind of marker in the database. We have one sort of marker if somebody's got comments. We have one sort of marker if somebody's on free school meals. You also get in our banding system, there's stuff, how much do you want to know, right? In our banding system, we're taking it very seriously. You want to know everything, right, okay. I've got 2 minutes. Okay, right, free school meals. You're automatically eligible for stuff like Opportunity Oxford. Google Opportunity Oxford if you haven't heard of it. You don't need to do anything. You don't need to apply for it or anything, but there's this thing called Opportunity Oxford. You're automatically eligible for it if you're eligible for free school meals at school. There's things like the ways that we behind the scenes try and group candidates together. So look at, in the context of everyone, we group candidates together. We have quite a detailed scoring thing. This is not the only thing we use to shortlist. We have a scoring system, and then we group people together into 4. We call them bands. Being eligible for free school meals gets you automatically into the most disadvantaged bands, so that tutors are aware that it's one of the indicators of disadvantage. Solutions to STEP questions are way more thorough. You actually learn from them. I did all the math, went to STEP. Where are you getting your STEP solutions though? It's not the Cambridge website, is it? Denim would like detail as well. About to hit 7 o'clock. I'm not really sure if I've given you enough detail or too much. Behind the scenes processes. Yeah, so Sagan wants this video as well. Never sure how much I'm supposed to say about the behind the scenes process. I mean, it's not secret, but you have to do it I have this tendency to talk fast and to cut corners when I'm talking and to say things and try and simplify things and get rid of a lot of details. These things are very nuanced, they're very complicated, they're very sensitive, and that doesn't really fit my style of how I do the live stream talking, so I have to be really careful. Which questions did I write? I did 1, 2, 3, 4, and 4. I had a great time. Prisma's off. It's not that deep, and you'll be okay, says Prisma. See you all and stay safe. Thanks, Prisma. Prisma's gone. Right, good. Zoe's gone. Prisma's gone. Do I like STEP? Yeah, I like STEP. I think it's a good test. It's really hard. Maybe that's not something I like about it. Right, okay, 7 o'clock. I think we're wrapping up. We've done a bit of a weird live stream. What are we doing? We did a bit of maths, even though I said I wouldn't. We've done a bit of polar coordinates. This was fun, wasn't it? Or parallel universes or something. Or different images of the normal universe. Alternatives are available for your choices of r and thetas, including some pretty weird alternatives like this left one. We learned about polar coordinates. Kai learned about parametric equations. Maybe other people as well, who knows? Sorry to pick Kai out. You asked for it. Complex number. You asked to learn about it, sorry. You asked for it is quite an aggressive phrase. We saw an integral that I can't do, and we made fun of my personal statement. We did not do any graph theory, so I can save that for Maths Club starting in January. Right, people are off. I want them so much. It's just worked out. This is where we leave, right? I'll wait for it to fit on screen. There it is. Bye. I'm so sorry. I'm so sorry. Right, we're back in 2 weeks. I'm taking next week off to actually mark the thing. And then we're back in 2 weeks to talk about the 22 test in more detail. Bye everyone, take care.